So let us see the case when we do not know what are the limits of integration. What are the limits of integration in the triple integral case? In the triple integral. So for this, let us see a question. So the question is, you have to evaluate this triple integral of the function x square y z dx, dy and dz over the region bounded by x is equal to 0, y is equal to 0, z is equal to 0 and the line x plus y plus z is equal to 1. This plane and these three lines. So the first step here is to see what are the limits of x, what are the limits of y and what are the limits of z. So for that we will visualize this region. So here, because we have three coordinates x, y and z, so we will have three x's, x, y and z. So this is your coordinate axis. Now x is equal to 0 means what we are talking about. X 0 means we are here. So this whole plane is your x is equal to 0, right? So this plane is x is equal to 0. Y is equal to 0 means z. Y 0 means this portion. That means this is your nothing but zy plane. Y is equal to 0 means this is your xz plane, right? So this plane is this one. And z is equal to 0 means this is your xy plane. So this is this particular portion and this is your origin, right? So these three planes, and we have this plane x plus y plus z is equal to 0. So obviously, what are the points on this plane? So you have one point as when x is 0, y is 0, what is the value of z? Its value is 1. So one point is this one. When x is 1, the other 2 points are 0, and when y is 1, the other 2 points are 0. So these 3 points lie on the plane x plus y plus z is equal to 1. So your plane would pass through these 3 points. Say this distance is 1, this distance is 1 and this distance is also 1. So your plane would pass through these 3 points. So it would be like, say your plane would be something like this, right? So this might be your plane, this one. Now we have to calculate what is the volume, and for that we have to determine the limits of integration. Now what are the limits of integration? If you see from this, from here, x plus y plus z is equal to 1, you can calculate what is the value of z. Its value is 1 minus x minus y. So you can write the variable limits of z containing both x and y first. So z varies from, what is the lower value of z? It cannot go below 0. So its lower value is z is equal to 0 and the higher value is 1 minus x minus y. And here you will write your function as such, x square y z. Here we have written the limits of z, then we will write the limits of y, and then we will write the limits of x. So here we will perform this integration with respect to y, and here we will perform the integration with respect to x. Now for the second limit, y is equal to, now we have to go and look for the limits of limits in y. We will check for limits in variable y such that it may contain x only. It may contain x only. That means there should not be any z. So one thing is given to you, z, y is equal to 0 in the question. But for the other limit, we will again consider this plane x plus y plus z is equal to 1. Now here, instead of, because we want only x, so we will not take this term x. Why? Because we will consider it to be independent of z. Because the first thing that we are doing is we are taking the variation of, say, origin to suppose this is origin point. From origin you assume one line moving out of your screen, right, towards yourself, so it will touch this plane. So at origin, that is the entry point of the region, and the exit point of this region would be this plane towards yourself. So at that point the value of z is equal to this one. These two values are clear. For the values of y, what we are doing, we are taking the projection of this onto the xy plane. So whatever is the projection, we are taking this projection over here, and then accordingly we are taking a line parallel to y-axis, such that we will look at what are the limits here and what are the limits here. So basically in this case we will instead of this we will assume x plus y is equal to 1, so that, because here in this case we are assuming z to be the variation is considered to be independent of z. So that means your limits will now vary from y. From here you can calculate the value of y, that is 1 minus x. So in this case your limits go from 0 to 1 minus x. So you have 0 to 1 minus x. And for the limits of x, we want the limits in x such that it may contain only the constant terms, no term in y and no term in z. Constant terms. So that means it should be independent of both x as well as y. So that means this x is equal to 0 is given to you in the question. This is your lower limit, and for the upper limit we again consider this x plus y plus z is equal to 1. Now because it is independent, x is independent of y and z, so that means the maximum value of x is going to be 1 from here. So our limits in this case become 0 to 1. So this is how you define the limits. Now you have your integral. The next step is to evaluate this integral. So let's do that. So your integral is from x varying from 0 to 1, y varying from 0 to 1 minus x, and z varying from 0 to 1 minus x minus y of the function x square y z. Now firstly we'll write the limits of z, then we'll write the limits of y, and then we'll write the limits for x. So this quantity is equal to, firstly we'll perform the integration with respect to z, so that means we'll solve this much portion. So we'll assume these quantities to be constant here. So as these are constants, so we'll keep them as such. And what is the integration of z? It is z square by 2, and we will take the limits from 0 to 1 minus x minus y, and then we have dy and dx as such, and then we can substitute the limits. So we will have x varying from 0 to 1, y varying from 0 to 1 minus x square y as such, and then we can also take 2 outside, so z square would be 1 minus x minus y whole square, and then we have 0, right? So the lower limit is 0, and we have dy and dx. So now we can solve this and perform this integration with respect to y now. So we have x is equal to 0 to 1 dx as such, and then x square as such, because this x square by 2 in fact as such, it is constant, and then the integration of integration with respect to y of y into 1 minus x minus y whole square dy. So firstly we'll solve this particular thing. Now what would be this? Here x would vary from 0 to 1, x square by 2 as such. Here we can use by parts. So this is first function, this is second function. So first function as such, the integration of second, so that would be 1 minus x minus y whole raised to power 3 divided by minus 3. 3 is because of the power and minus is because of the coefficient of y here. And for the second part we have minus integration derivative of first, so integration here is y varying from 0 to 1 minus x, derivative of first, that is 1, and then integration of second is again 1 minus x minus y whole cube divided by minus 3 dy. So this is what we have into dx. So this thing is equal to integration x varying from 0 to 1 x square by 2, and then you have, when here also we will write the limits for y. So the limits would be from 0 to 1 minus x. So we have 1 minus x into 1 minus x minus 1 by x. So this and this cancel. So your first term is equivalent to 0 when you substitute the limits. And when you substitute the lower limit here, it is 0. So you multiply by 0, that is 0. So we have 0 minus 0. And for the second case we have plus 1 by 3, and then the integration of this quantity, that is equal to 1 minus x minus y raised to power 4 divided by minus 4. And here also the limits of integration are from 0 to 1 minus x dx. So this is the integration with respect to y. So let's simplify this a bit. So what do we have? We have x square by 2 as such, and then we have minus 1 by 12, and instead when you substitute this limit 1 minus x, so you will have 0, so you substitute the lower limit, so that would be minus of 1 minus x raised to power 4, yes, into dx, right? So this is what you have. Now the next step is this minus and minus becomes plus. So we have 1 by 24 and integration x varying from 0 to 1 x square into 1 minus x to the power 4 dx. Now its integration is very simple. The integration of x square is x cube by 3, and the integration of not like this, you cannot perform like this. So how can you perform this integration? Again using the by parts. So its integration would be first function as such, the integration of second minus integration of integration derivative of first, and then integration of second. So 1 minus x to the power 5 by 5 dx, right? And here also you'll write the limits x varying from 0 to 1, and here also x varying from 0 to 1. And next we have, so for the first term when you substitute the limits, you have 0 this becomes 0 only, and for the second term minus 2 into, here also we can apply the by part. So we have 2 by 5 outside, so this become equal to 2 by 5 outside minus outside, and then integration from 0 to 1 of x 1 minus x to the power 5 dx. So this is equal to minus this 2 and 24 cancels, 12, we have 1 by 60, and then the integration from 0 to 1, this is first function, this is second function, so we have first function as such, integration of second, so that is minus 6, and here also we have minus 5, so this is plus actually, yes, and moreover minus integration derivative of first, that is 1, integration of second 1 minus x to the power 6 upon 6, yes, dx. The limits from 0 to 1, here also the limits from 0 to 1. Okay. So finally when you substitute the limits, when you substitute 1 again you have 0, when you substitute 0 you again have 0. So you have 1 upon 60 into minus 1 upon 6 into 1 by minus x raised to power 7 upon 7, and here minus 7 actually, and the limits of integration from 0 to 1. So finally when you substitute the answer finally would be equal to 1 divided by 2520. So this is the answer. In a similar way, we have one more question. We can discuss one more question. The question is, evaluate the triple integral of the function z square dx dy dz and here the region is defined to be this unit sphere. So the equation is x square plus y square plus z square less than equal to 1. So you have the unit sphere like this. So this is x-axis, this is y-axis, this is z-axis, this is origin. So it is having center at origin and radius as 1. So this is some kind of sphere having unit radius and center at 0 in 3-dimensional plane. Okay. So this is 3D diagram. So here in this case we have to evaluate this. So basically what is our region here? So our region is simply defined by all the points x, y, z such that these points lie between these limits x square plus y square plus z square less than equal to 1. Or now we can define the limits individually. So individually your limits become all those points x, y, z such that now here we have to write 3 limits. One is for z, one is for y, and one is for x, right? So we'll start with the variable limit. So we have this integration, triple integration over x square plus y square plus z square less than equal to 1 of the function z square with respect to dx, dy and dz. This is what we are required to calculate. So firstly we will check out the limits of x. So here are the limits of x, here the limits of y, and here the limits of z. We have z square, dx, dy and dz. Now for the limits of x, what do we require? We require the limits such that the limits are limits of x may be functions of both y and z. So it may be functions of both y and z. So in this case you will start from origin, or in other words you can solve this thing. You have this x square plus y square plus z square less than equal to 1. So from here you can evaluate what is the value of x. Yes, you can evaluate what is the value of x. If you have this equality, the value of x comes out to be 1 minus y square minus z square, square root. So you have plus minus. So that means your lower limit becomes minus square root of 1 minus y square minus z square, and the upper limit becomes square root of 1 minus y square minus z square positive. And for the limits of y, these limits may be function of x but should not contain they might be function of z, this outer variable, right? But they should not contain x, this inner variable. So in this case, what are the limits? So we will again consider this. So we will have x square plus y square plus z square is equal to 1. So now because we are taking the limits to be x independent, so that means we will take y square plus z square is equal to 1. So from here you can evaluate what is the value of y. This would come out to be plus minus square root of 1 minus z square. So that means your lower limit becomes minus of this quantity and the upper limit becomes plus of this quantity. So this value is minus square root of 1 minus z square and its value is square root of 1 minus z square, positive quantity. And for the values or the limits of z, they should be constant. That means they should be independent of both x and y. So that means if you take this surface again, x square plus y square plus z square is equal to 1, and you want it to be independent of both x and y, so that means you will take the quantity z square is equal to 1. So that means you will have z is equal to plus minus 1 from here. So that is your limits. So the value of z is minus 1 here and plus 1 here. So this is how you define the limits. Now the next task is to solve this. So let us now solve this integral. So evaluating this, we have integration minus 1 to 1, integration minus square root 1 minus z square to square root 1 minus z square, and integration minus square root of 1 minus y square minus z square, square root of 1 minus y square minus z square, and then z square dx, dy and dz. So first task is to solve this inner integral. Now you see this function, this is an even function, and you have the limits from minus same quantity to same quantity. So that means you could convert this limit into the limit from 0 to the same limit and 2 times of this function. So it becomes 2 times for this limit, 2 times for this limit, and 2 times for this limit. So that means your limits now reduces to 0 to 1, integration from 0 to square root 1 minus z square, and then integration from 0 to 1 minus y square minus z square square root, and the function z square dx, dy, dz as such, because this x square is an even function. How this is an even function? Because if you have your f of x is x square, if you write f of minus x, that would be minus x whole square. So that is equal to, so this thing is equal to plus x square only, which is equal to f of x. So that means your function is an even function. Okay. So now we can simplify this. Firstly, we'll perform this integration with respect to x. So here we have 8, and then from 0 to 1, from 0 to square root 1 minus z square, 1 minus z square, and then integration would be x into z square, and then the limits of x from 0 to square root 1 minus y square minus z square, dy dz as such. And then now we can substitute the limits. So this would be 8, integration 0 to 1, integration 0 to square root 1 minus z square, x as such, z square as such, because we will substitute the limits of x. So this would be equal to 1 minus y square minus z square square root into minus 0. So this is what we have. Now we have to perform the integration with respect to z. So what would be this? Now z square is this constant quantity. So we'll perform this integration of this quantity. And the integration could be written like this. You have this formula. Integration of a square minus x square, that is equal to x by 2 square root of a square minus x square plus a by 2 sine inverse x upon a. So this is the formula. We'll use the same formula for y here. What would be this? Integration from 0 to 1, from 0 to square root 1 minus z square as such, because this is constant with respect to y. So we can write this term to be 1 minus z square minus y square. So that means this becomes your a square and this becomes your variable square root. So in this case, what is your formula? Your formula becomes y by 2 and the square root as such, 1 minus z square minus y square, and then plus x, the variable, plus a by 2. What is a here? Square root of this quantity. So square root of 1 minus z square divided by 2 sine inverse of the variable, that is y, divided by the constant a, that is 1 minus z square square root. And its limits, they vary from 0 to square root of 1 minus z square into dz. Yes. And we would not write these limits here. So it is simply the brackets. So next we will substitute the limits over here. So what would be our limits? So our limits would simply be equal to, so this becomes, the calculations are quite lengthy but it's okay. So you have z square as such, and then when you substitute the upper limit here, this quantity will become 0, and when you substitute the lower quantity, this quantity again becomes 0. And for this term, when you substitute in place of y, so you have 1 minus z square square root by 2 as such, and then you have sine inverse of 1. When you substitute in place of y, you have 1 minus sine inverse of 0 dz. So this is what you have. Now this thing is equal to integration from 0 to 1 z square 1 minus z square square root by 2, and then sine inverse of 1, that is equal to pi by 2, and sine inverse of 0 is 0. So this is equal to this cancels with this, so you are only left with 2 pi, right? 2 pi integration from 0 to 1 z square 1 minus z square dz. Now its integration is very simple. What would be this integration? I'm sorry, here we have the square of this quantity. Why? Because in the formula it is equal to a square here. Okay, so we have this quantity. So how can you solve this? 2 pi as such, 0 to 1 z square minus z to the power 4 dz. So its integration simply is z cube by 3 minus z power 5 by 5, and then the limits of integration from z varying from 0 to 1. So this is equal to 4 pi divided by 15. This is the final answer. So I hope this topic is clear to you all.